Yes. Hello, everybody. Good afternoon. So, let's start today's session. Okay. Manufacturing process Super 20. Okay. So, here we are going to solve questions. Yesterday, we covered the entire theory of manufacturing process part 2. And today, we are going to solve questions, right? Based on yesterday's session. So, I hope you guys are ready. So, let's start. So, theory of metal cutting, tool life, NTMM, non-traditional machining method, welding, NC, CNC, machine tool, and additive manufacturing. Additive manufacturing. Yes. So far you have covered strength of material, manufacturing process part 1, basic thermodynamics, right? Okay, this is for your Maha revision. So far you have covered in Super 20 the strength of material, manufacturing process part 1, basic thermodynamics. Today we are going to start manufacturing process part 2. Okay, so let's start. So here's your question. Your time starts now. Okay, so yes, you are right. Very good. Here, accuracy of the tool's cutting edge geometry. Basically, the question is which of the following parameter primarily govern? Okay, primarily govern govern the failure criteria and end of the tool life, or life of the cutting tool during machining operation. So, accuracy of the tool cutting edge geometry, no. Mechanical property of the work material, no. Schedule of tool reconditioning or maintenance, no. Rate of wear, by which rate a wear is progresses on the cutting tool will decide the tool failure rate and life of the tool. So the correct answer is option C. Very good. Now the next question is, uh, yes. Yes, in ultrasonic machining, which material characteristic play the dominant role in determination its machining? Elastic module of the material. In ultrasonic machining, which material characteristic play a dominant role in determining its machinability? If the workpiece is brittle, then the fracture can easily produce on the surface and it propagate, right? And it propagate. In ultrasonic machining, I will repeat it again. What is going to happen in ultrasonic machining? If the machining workpiece is what is brittle, then what happen? Due to indentation of abrasive particle, the crack will initiate on the surface and propagate, and machining will occur. So, elasticity, due to elasticity module of the material, it will not help in ultrasonic machining. Tendency of material to fracture under impact, yes. Ability of the material to conduct heat, no. Electrical conduction capability of the material. So option B is the right. Next. Yes. So in the electrical discharge machining process, which parameter has the most significant influence on the effectiveness of material removal? In EDM process, which parameter has the most significant on the effectiveness of the material removal? Separation between the tool, electrode and workpiece, hardness of the electrode material, no. Linear travel speed of the tool, no. Surface color of the workpiece, no. Separation, that is spark gap between the tool, electrode and workpiece. If the gap vary, then spark is not stable and it will not produce the machining operation. So also the desired profile of the tool will not generate it on the workpiece. So option A is the correct one, right? Yes. Yes. Yes? Any answer? So far, okay, here's the time is up to, okay, C and B. C and B, 80 meter per minute, okay. And so, shall I solve? If you try it by yourself, if you have tried, okay, shall I? Okay. So, here I am going to solve this question, right? Here I am going to solve this question. Look, for a turning operation, the following information is given. Tool changing time is given. Tool regrinding per or repairing time is given 4 minutes. Machining cost 12 rupees per hour. Tool depreciation cost is 30 paisa. Tailor tool life constant N and C are given, right? Here N and C are given to us. Now we know that tailors using the minimum cost criteria, the optimal cutting speed. For that, we know one thing. What? The optimal tool life. Optimal tool life. Tool life for minimum. For minimum, right? For minimum cost. That is what? T naught equal to TC plus CT by CM 1 minus N by N. Am I clear? Am I clear? Okay. Now, here, CM is what? CM is given. So, let me convert that CM into rupees per minute. That is what? 12 by 60 rupees per minute. Okay. So, 12 by 60, 12 by 60, 0.2 rupees per minute. Now, this is CM. Now, tooling cost. I told you, yesterday I told you, what is the tooling cost? It is, here I am going to write on the new slide so that you remember. If you forget, what is tooling cost? CT, that is your regrinding cost, regrinding cost, tool regrinding cost plus tool changing cost, tool changing cost plus depreciation cost. Because most of you have not given the right answer, that's why I'm writing. Now this is CT. If this is CT, then regrinding. Here, regrinding time is what? Regrinding time is 4 minutes. So, who will do the repair? Basically, operator. Operator will do machining. So, CM into TR. Who will change the tool? Operator. Basically, he is also doing machining. So, CM into TC plus depreciation cost. So, CM, that is, okay, TR, that is 4 minute, right? TR, that is 4 minute, and 0.2 into 4 plus 0.2, changing time is what? 6. Changing time is 6 plus depreciation 0.3 rupees, because it is in paisa, 0.3, right? 0.3. So, 0.2 into 4 plus 0.2 into 6 plus 0.3, 2.3 rupees per service. Okay. Now, T naught is TC plus CT by CM 1 minus N by N. T naught TC. Tool changing time, that is 6 plus 2.3 cm 0.2 1 minus N, that is 0.25 0.25 0.25 0.25. So here comes the T naught. 2.3 divided by 0.2, answer plus 6, answer multiply 1 minus 0.25, answer divided by 0.25, that is 52.5 minute per service. So V naught T naught to the power n equal to C. C that is 180 divided by T naught 52.5 to the power 0.25. So 180 divided by T naught to the power 0.25. So 66.87 meter per minute. So nearby we can write 67 meter per minute, right? So option B is the right. Anybody has any doubt? Because most of you have given option C as answer. Aditya, Divya, Swastik, okay, Devapalli, Shiv Kumar, am I clear? And some of them have given option A also. Mukhu, Srivastava, Aditya, Kotawade. Any doubt? Any doubt? I have given the detailed explanation of this question. Okay, I have given the detailed explanation of this question. Any doubt? Shall we move? Clear? Okay, let's move. This is a easy question. Okay, Aditya, Kothavade, got it. Thank you. Okay. Question is very easy. You will get the value of n. Once you solve, you will get nearby value 0.45. The exact value is what? 0.446, but when you round it off, 0.45. Now V1 T1 to the power n. So V1 50 36 0.45. The value of C is 247. 247. So option C is the right choice. You people are doing good job. Yes. So option A. Okay. Ultrasonic machining, USM. You need what? Abrasive slurry. So A2, right? Electrical discharge machining. Need dielectric medium, that is kerosene based oil. Electrochemical machining. We need electrolyte, that is salt solution, C. And electron beam machining. Okay, electron beam machining required. Sorry, it is 4. And we need vacuum. So option A is the right choice. Right? Next. Are you sure? Yes. A solid cylindrical workpiece is turned on lathe at a spindle speed of 750 rpm. The workpiece diameter is 80 mm and the depth of cut is 2.5. During machining, the force component measured at the tool tip cutting force is this much. Assume steady cutting, assume steady cutting and neglecting power losses, the power required for machining. It is simple, that is cutting force into cutting velocity. So what is the cutting velocity here? That is pi dn divided by 1000. Pi d diameter is 80 mm and rpm is 750 divided by 1000. Now this is meter per minute divided by 60, so it is meter per second. Now power consumption is what? Cutting force into velocity, that is 1500 pi d n divided by 1000 into 60. So 1500 into pi into 80 into 750, answer divided by 1000, answer divided by 60. So it comes 4.712 kilowatt. In this easy question, you people are doing mistake. Okay, so please pay attention. This is a very easy question. Okay. In electrical machining operation, 3.2 centimeter cube per minute of nickel is to be removed from workpiece. The property of the nickel, assuming 100% current efficiency. So, MRR equal to I into E divided by F into rho. That will centimeter cube per second. Here MRR is centimeter cube per minute. So 3.2 divided by 60 equal to I divide by divide by E, that is atomic weight 58.7, valency is 2, F 96500 multiply density, that is 8.9, right? So when you solve, yes, so 3.2 divided by 60, answer multiply 96500 multiply 8.9, answer divide by 58.7 divide by 2. So yes, I is 1560.65 ampere. Okay. Next. Yes. During turning, a single point cutting tool has tool signature given depth of cut D, feet is 0.2 mm per revolution, coefficient of friction at the tool chip interface 0.5. Shear stress of the work material is 450. Assuming merchant analysis is applicable, the cutting force is. We need to find the cutting force. Okay, in the comment box, let me know. Please tell me which system is that. Is it ASA and ORS? At least tell me in the comment box. Is the angle is ASA system or ORS system? Okay, very good. Yes, the system is ASA. The system is ASA. Very good. So, to find the, because somehow we need the shear angle. Okay, somebody has solved 698. I think it is 6 nearby the answer. 698 nearby, not exact, right, Saurav? So please check your calculation again. You are nearby but not the exact one. So we need the shear angle. For shear angle, we need orthogonal rectangle. We need orthogonal rectangle first of all. Then we need shear angle. But in this question, orthogonal rectangle is not given. So how can we find? By interconversion formula in between ASA and ORS, right? By interconversion formula in between ASA and ARS. Are you getting my point? By interconversion formula in between ASA and ARS. So what is the interconversion formula? Tan alpha equal to, here we need alpha. So we can write tan alpha equal to tan alpha s, that is side rake angle into sine lambda plus tan of back rake angle cos lambda. What is lambda here? This is CS. So lambda is 90 minus CS. Right? Lambda is 90 minus CS. So here comes your lambda. That is what? 90 minus 25, that is 65. So 65 degree. So when you calculate this, tan alpha, now this is back rake angle and this is side rake angle. So tan of alpha is, so tan of 12 and sine of 65 plus tan of 8 cos of 65. So you will get the value of alpha. Tan of 12 multiply sine of 65 plus, okay, plus tan of 12 multiply sine of 65 plus tan of 8 multiply cos of 65, right? Shift tan inverse answer. So alpha is 14.14. Are you getting this? Alpha is 14.146. or if I can round off 1.4, 14.5 degree. And now we need the shear angle. But for shear angle, if we apply the formula, that is tan phi equal to r cos alpha 1 minus r sin alpha. There is no r. So by this formula we can calculate the phi. So what to do? In that case, it is given that assuming merchant analysis is applicable. So phi is 45 degree plus alpha by 2 minus beta by 2. Here mu is given. So you can write that tan of beta equal to 0.5, right? So beta equal to 26.565, right? 565. So here we get the value of phi 45 degree plus alpha by 2, 14.15 by 2, right, minus 26.565 by 2. 45 plus 14.15 divided by 2 minus divide by 2, that is 38.792. Is that clear? Is that clear? So this is the shear angle value. Now can we find the shear force? Shear force is tau s, tau naught into as. So tau naught is given 450 megapascal, that is Newton per mm square, 450. As is what? W T naught by sin phi. Now depth of cut and feed. Now this is turning. So we can write 450 multiply FD divide by sin phi. In turning we can write FD also. So what is shear force? That is feed is given 450. Feed is given. What is that? 0.2. D is 3. Divide by sin 38.792. So here comes the shear force. So here is 450 multiply 0.2 multiply 3 divide by sin of phi, that is 430.964 Newton. Right, now you have the shear force. Now you have the shear force. Now what will be the next step? We can find the R, right? We can find the R, and actually what he is saying, actually let me recorrect the actual cutting force. The actual question is the actual cutting force. Is that okay? The actual cutting force. The actual cutting force, that is what? R. Sorry for your inconvenience. And because you cannot find, you will not able to find the, okay, if you are calculated the R, if you have calculated the cutting force, manufacturing to telegram link. Now let me calculate here Fs. Fs equal to R cos phi plus beta minus alpha. So it will give what? R. Okay, it will give what? R. So answer divided by cos of phi, that is 38.792 phi plus beta 26.565 minus alpha 14.15. So 687.88 Newton. This is the actual cutting force, but if you are calculating the FC, then what is FC? FC is R cos beta minus alpha. So 687.883 cos beta 26.565 minus 14.1, I think 5, right? 26.565, 14.15. So this is the cutting component. Answer multiply cos of 26.565 minus 14.15. So 671.797 Newton. Very good. Is it clear? Is it clear? Everybody? Although the question is lengthy, but we need to do a practice here. Okay, we need to do practice here. In this question, various formula comes, right? So first is this tan alpha formula. Second is your merchant analysis, right? And third is your merchant circle formulas. So 3 to 4 formula come in this question. Okay. This question may be asked in MSQ type also. English में मजा नहीं आ रहा, आता सर वो वाला. What to do, my dear? What to do? This question may be asked in MSQ type. Right, right. This question may be asked in MSQ type. Okay. ORS ADI in which dimension SOR. Okay. So I hope this question is crystal clear to all of you. Now let's move to the next question. Okay. For a turning operation, the tool life relationship is given by under the cutting condition, cutting speed, feet, depth of cut, the observed tool life. If the cutting speed, feet, depth of cut are increased by 20%. So basically this is V naught, F naught, D naught and T naught, right? And if you increase the cutting velocity V1 by 20%, then 1.2 times of what? 30. F1 is what? 20% if you increase 1.2 times of 0.25 and here D1 is 1.2 times of 2. So that much will become, okay, that much will be come. Now here this is equal to, let's calculate it here 20% now. Okay, we are increasing it by 20%. Okay, so if we are going to increase by 20%, now here 1.2 into 30, 36. Okay, 1.2 into 0.25, 0.3 mm, 1.2 into 2, 2.4 mm. Now here this is what? V naught, V naught, T naught to the power 0.2, F naught to the power 0.4 and D naught to the power 0.3 equal to V1 into T1 to the power 0.2 F1 to the power 0.4 and D1 to the power 0.3. So we can find the T1. Here V0 is 30 multiply T0 is what? 50 to the power 0.2. Okay, F0 is 0.25 to the power 0.4 and D0 is 2 to the power 0.3 equal to V1, that is 36 multiply T1 to the power 0.2 F1, that is 0.3 to the power 0.3 to the power 0.4 and D1, that is 2.4 to the power 0.3. So here we calculate the T1, right? So 30 multiply 50 to the power 0.2 multiply 0.25 to the power 0.4 multiply 2 to the power 0.3. Okay, answer divide by 36 multiply 0.3 to the power 0.4 multiply 2.4 to the power 0.3. So answer to the power 1 divided by 0.2. So it comes 10.615. Is it correct? First, let me know, is the value of T1 is correct? Is the value of T1 is correct? Is the value of T1 is correct? Now, he is asking the tool life decreased by, that is change, right? That is T1 minus T0 decrease 50 minus, okay, sorry, 10 0.615 minus 50. So minus 39.384 minute. So shows the minus sign shows that tool life is decreases by 39.384. Is the solution is clear? Yes. Is the solution is clear? Is the solution is clear? Yes. Is the solution is clear? Yes. Okay. ओआरएस और एएसए में नोज डायमेंशन कल बताया था ना। एएसए में इंच में होता है नोज रेडियस और ओआरएस में एमएम में होता है। बस तन्मय बरी। ओके। Okay. In an electrochemical machining, the iron surface cross-section area, NaCl electrolyte, the interelectrode gap, 12 volt DC, the specific resistance is this much, density, atomic weight, material removal rate. Okay. So for material removal rate, we need what? I. I is not given. So current density into specific resistivity, applied voltage minus drop voltage divided by Y. So J, that is I by A into S V naught. It is not given, so we can keep it 0. Now I by A. A is, it is 40 mm into 25 mm. So I am writing 4 into 25, 4 into 2.5. Okay, centimeter square. Multiply 1.5 ohm centimeter, 12 divide by Y, 0.3 mm. So 0.03 centimeter. So here you will get the current value. So 12 divided by 0.03 multiply 4 into 2.5 divide by 1.5, that is 2666.66, okay, 6 ampere. Now MRR is I E by F rho. So I is 2666.666 E, that is atomic weight 656 by 2 divide by F 96500, density 7.87. Answer, multiply 56 by 2 divide by 96500 multiply 7.87. So MRR is 0.0983 centimeter cube per second. 0.0, right? Aman Kumar, it is 0.09, not 0.9. Okay, Akshat, very good. Yes. So, which of the following statement about electrochemical machining process is are correct? ECM can machine very hard and tough material with negligible tool wear. With because of this statement, negligible tool wear, you can say option A is right. The material removal rate in ECM is independent of electrical conductivity. The ECM produce component without thermal damage or burr formation. Yes, the choice and property of the electrolyte have little influence on the ECM process. No. So A and C is the correct one. Okay. A and C are the correct answer. Now the next. No. My dear, if you displace the tail stock, then surface finish. Please pay attention here. Actually, in this option, na, what examiner did, he has given employing a taper turning attachment. And you have seen that taper turning attachment is a, a basically advanced tool which provide accurate accurate taper and good surface also. A small, either you can produce a small taper or large taper, but the taper will be accurate if you use taper turning attachment. Are you getting my point? If the taper turning attachment is not available, then you can use either what? Either by using swiveling the compound slide, either by offsetting the tail stock, either by using the form tool, right? But accurate taper on a lathe. So option C is the right choice. सर लास्ट क्वेश्चन में ऑप्शन बी गलत क्यों है, एक बार समझा दीजिए प्लीज। बिल्कुल, ये समझ में आ गया क्या? ये समझ में आ गया क्या? ये समझ में आ गया क्या? एम्प्लॉय अ टेपर टर्निंग अटैचमेंट। हाँ, लास्ट क्वेश्चन देख लेते हैं। द मटेरियल रिमूवल रेट ईसीएम इंडिपेंडेंट ऑफ इलेक्ट्रिकल कंडक्टिविटी। भाई इंडिपेंडेंट नहीं है ना, डिपेंड तो करेगा ही ना। जितना ज़्यादा कंडक्टिविटी अच्छी होगी उतना ही करंट अच्छा रहेगा, और आपका इलेक्ट्रोकेमिकल मशीनिंग करंट पे भी तो डिपेंड करता है ना, इलेक्ट्रिकल कंडक्टिविटी भी तो इम्पोर्टेंट है ना, राइट? ये कह रहा है इंडिपेंडेंट है। यहाँ पे ये ऑप्शन देके इसने खेल कर दिया, और इधर जो लैंग्वेज यूज करी है ना, एक्यूरेट टेपर, इसने यहाँ पे खेल कर दिया है। इन दो के कॉम्बिनेशन से फिर ये मुझे सेलेक्ट करना पड़ेगा। आई हैव टू सेलेक्ट ऑप्शन सी। ओके, Yes. In the production of high-speed steel drill, which weld technique is commonly used to join mild steel shank with a drill body? Generally, we use flash butt welding. Okay. Generally, we use flash butt welding. So please remember this. This question is straightforward. A groove is 6 mm thick molybdenum plate. The molten weld cross section area, okay, assume approximated as semicircular of radius 2 mm and weld length is 120 mm. Specific melting energy of the molybdenum is given by this. Okay, so the required melting heat is what? That is into volume of the weld metal. So is what? Here it is into area of the weld metal into length. Okay, and this is equal to area of weld metal is pi r square, pi r square, that is pi 2 square by 2 into L, that is 120, right? So this is a volume. Simple, straightforward question. I mean, if I give the efficiency, then it will become a tricky, right? Then it will become a tricky. So here, shift pi into 2 square divided by 2, answer into 120, answer. This is what? This is 1.5. This is 1.5 into 10 to the power 6 t square, that is 18, multiply 753.9822. right? Joule. So answer multiply 18. Answer multiply 1800 square multiply 1.5 into 10 to the power minus 6. So 3.664 kilojoule, option B. Okay, question is pretty simple. Huh. B. Good. The answer is B. Okay. So here H input is I square RT. I is 3500 square R 0.0025. T is 0.2. Okay, joule. Now H actual is volume of the weld pool. The resistance, okay, a current is passed through. The volume, if the volume here into volume of the weld pool. So 360 into 6 melting efficiency, that is HA by HI into 100. HA is 360 into 6 divide by 35 square 0.0025 0.2 multiply 100. So 360 into 6 divide by 3500 square multiply 0.0025 into 0.2, answer into 100, that is 35.265%. Option B, okay, is the right answer. Next. Very good. Here, distance is root of x2 minus x1 square plus y2 minus y1 square. So here is my calculator. 5 minus 5, right? 5 minus 5 square plus 38 plus 10 square, so 48 mm. Number of revolution. Okay, pitch is given. Pitch is how much? 3 mm. Here, pitch is 3 mm. Means what? Means what? For 3 mm linear distance, you need to give 1 revolution. But if you move by 48 mm, then how much revolution is required? 48 by 3, 16 revolution. Now, in each revolution, there is a backlash of what? 1.5 degree per revolution, right? In degree, total backlash, okay? In degree, total backlash for 16 and total backlash, right? Let's say this is theta t equal to 16 multiply 1.5 degree. So 16 into 1.5, 24 degree backlash. Now we need to convert in linear backlash. So we know that if we give 360 rotation, then 3 mm linear, okay, displacement. And if 24 degree, in 24 degree, if there is a backlash, then how much backlash will become? 24, this come here, this into this, and 24 into 3 divide by 360. So 24 divide by 360 multiply 3, 0.2 mm. Answer B. Next. Yes. Okay, good, very good. Here, you need to find the tangential force. MRR is given 6000 mm cube per minute. 6000 divided by 60 mm cube per second. 100 mm cube per second. Now, specific power energy. Specific power energy 18 joule per mm cube. That means what? Work done, that is power, divided by MRR, right? Okay. So here this MRR is 100. So the grinding power is what? 18 into 100. So 1800 watt. Watt. Okay. 1800 watt will be the power. 1800 watt will be the power. Now the cutting velocity is cutting velocity. Now cutting velocity is what? V equal to pi dn by 1000 pi d. So assume d, rotate, okay. Material removal rate is given. So what we should what we required? We required is what? Here diameter is given, yes, 300 mm. So 300 into 2000 by you can say 1000, okay, 60. So meter per second. So here comes the V. Here comes the V. Okay, if I keep it as it is, power is what? Cutting force into velocity, that is 1800 into cutting force into cutting velocity, that is pi 300 into 2000 divided by 1000 into 60. So 1800 into 1000 into 60, answer divide by shift pi into 300 into 2000. So it gives, that is 57.29 Newton. 57.29 Newton. Okay, clear? Very good. Next. Yes, very good. Chemical machining process on a flat aluminum plate. Okay, a rectangular pocket is to be etched. The pocket dimension is this much. The pocket dimension is this much. The etchant using a mixture of phosphoric and sulfur. The penetration rate of the etchant is this. The metal removal rate. So, metal removal rate is cross section area multiply 0.003 mm, right, this much. So it will be give you mm cube per minute. This is 15 into 10 into 0.003 mm cube per minute. So this is 15 into 10 into 0.003. So answer multiply 60 per hour, right? So this is the right answer. Okay. Now, next question. Very good. Here, in a straight turning operation, production target require complete one single pass, okay, in 2.5 minute. The workpiece is 180-meter long and 90 mm in diameter. The feed rate is this much and depth of cut is this much. The cutting speed is required. So here the machining time equal to L by Fn. So T is given, that is 2.5, L is 180 divided by feed that is 0.3 into RPM. So here comes the RPM. Okay, so that is 2 point RPM is what? 180 divided by 0.3 divided by 2.5. So RPM is 21.6. What's the RPM? Is it the 21.6, right? So RPM is 21.6 revolution per minute. Cutting speed is pi dn by 1000. Okay, so pi diameter is 90, 21.6 divided by 1000. So pi into 90 into RPM. So 6 point. I think I did some mistake. RPM is what, 21.6? Yes, I think I did some mistake now. I did some mistake. I did some mistake, है ना? Calculation mistake. Here 2.5 is the machining time. RPM is, yes, 2.5. L is 180 divided by 0.3 divided by 2.5. Yes. RPM is what? 240. 2.5, 180, 0.3 into N. RPM. Now here pi dn by 1000. So pi diameter is 90. 240 divided by 1000. Pi d n by 1000. 6785 meter per minute. Okay. Now, the last question from stereolithography. In stereolithography, following data is given. Following data is given below. Given below. Nozzle dia is 0.4 mm. Nozzle speed. Okay, nozzle speed is 40 or 400 mm. Okay, 400 mm per second, right? Dia, okay, okay. Neglect repositioning time, neglect repositioning time, then the building part, building time building time of the part in second. Part is what? Part I am drawing here. ओके सर, इसका पीडीएफ कहाँ मिलेगा? ऑन द ऐप, PW app, right? On the PW app, you will get the PDF. (21.6) thickness is not given. Thickness is not given. And I told you, if thickness is not given, then what to do? Thickness is not given. Look, if thickness is not given, if layer thickness is not given, then you can consider the nozzle dia. Nozzle dia is the thickness of the layer. You can take it if thickness is not given. So nozzle dia is 0.4, right? Now, here 0.4 mm, right? Now, this is part 1, this is part 2. Now, part 1, the first surface area is what? That is pi by 4 d square, pi by 4 d square, that is what? 100, right? Now, the required time, first required time for the first layer is, that is AI plus V into D. So pi by 4 d square divided by V, that is V is 400, multiply diameter is 0.4, right? That much second per layer, okay? Now number of layer for part 1 is what? That is 8 mm divided by the layer thickness. I can assume nozzle dia 0.4, so 20, right? 20 layers, 20 layers. So total time for the part 1, that is pi by 4 d square divided by 400 into 0.4 into 20. Similarly, for part 2, the area is pi by 4 d square, that is 50 square. The time required for the first layer, AI by V into D. What is AI? That is 50. What is AI? That is pi by 4 50 square divided by V. That is what? 400 into nozzle dia. Nozzle dia is what? 0.4. Number of layer is what? 6 divided by 0.4. Okay, 6 divided by 0.4. So 6 divided by 0.4, 15. 15 layers. So T2 is what? Pi by 4 50 square divide by 400 into 0.4 into 15. Now T equal to T1 plus T2. So what is T1 here? Pi by 4 into 100 square. Answer divide by 400 into 0.4. Answer multiply 20. 981.747 second. And here pi by 4 50 square. Answer divided by 400 into 0.4. Answer multiply 15. 184.077 second. Total 981.747. Yes, 1165.824 seconds. Okay. Yes, very good. So that's it for today's session. I mean, in the Super 20, we are going to meet at 7 p.m. in Mahabhyas batch. Okay. In Mahabhyas batch, we are going to solve 30 more questions. Are you getting my point? We are going to meet in Mahabhyas batch at 7 p.m. today. Right. In that session, we are going to solve 30 more questions. Okay. Thank you.